your program that you did, rectangle approximation, you might want to test this thing out with the rectangle 6. But I'm going to show you how to get exact area with your calculator, and then how to also get that exact area using geometry in some functions. Not all, it's not always possible to do it, but some of them. Okay, so take your calculators out. Okay, and then, well, electronics works so much better if you turn it on, by the way. Okay, so here, and then let's clear this thing from algebra 2, and then let's enter this, x cubed minus 6x, right? Oh my God, I screwed up, right? I should watch what I'm typing. X cubed minus 6x. Okay, shall we take a look at this function first? Yeah, let's do that. So zoom 6, standard window. Okay, this shows up, right? Let's zoom into this area now, shall we? Because it says from 0 to 3. So window setting from 0 to 3. And how high was it and low? Do you guys remember? Was it like 7-ish? Whatever. Something like that. So this shows up, right? Now, any prediction on what this integral, which is area, this area and that area, right? One would think, what would that be, right? Should we do it with a quick way instead of trying to impress your study date? Yeah, let's do it the quick way, okay? Yeah, quit. We already know how to do that skill, so it's like we don't have to learn it again. Okay, so hotkey was math and 9, right? I'm gonna scroll to show you this is the hotkey, math 9. You can just hit math 9, and then this shows up, right? And I'm gonna write down the syntax of TI-83 people, okay? So, and from 0, scroll 3, scroll, and you don't have to type this function in. Remember, we stored it into y1. So what we can do is, remember how to bring y1? Alpha, trace, there's your y1. You get it? Y1 goes here, and then x goes here. And I'm gonna eventually explain what that x means. Okay? And then, boom. What? Negative 6.75? Did you expect that? Whoa, whoa, whoa. Okay, I'm gonna screenshot this. Okay, I'm gonna save it somewhere here. Like, what is that negative area doing, right? Let's go back. Let's go back to graph. I'm gonna screenshot this as well. And then I'm gonna save it somewhere here. Well, I'm gonna switch this. Let's do it this way. Now, somebody explain to me what is going on here. Why are we, there's no such thing as negative area. So this thing called the integral, oh, by the way, TI-83 people, this is your syntax. TI-83. Huh, this thing is not working. My pen is not working. Oh, now it's really, really laggy. Kara.
Oh, sorry, I was just gonna say, is it because like the y value is negative, so when the calculator calculates the area, it's like negative?
Uh-huh. Wow, this OneNote is not working. I'm sorry, TI-83 people. Do you remember what I showed you? I saw the note yesterday, well, Friday, right? This OneNote is not working. So what's going on? I'm going to have to teach this without writing it down, which makes it uniquely difficult. This is not exactly the area. This is, think of it as a displacement when this is a velocity function. Imagine rectangle approximation, you're drawing rectangles here. All those height of the rectangles turns out to be negative, and you're multiplying by a certain width. In this case, if you're using 6 intervals within from 1 to 3, then each delta x is a size of 0.5, isn't it? I really wish I can write this thing or draw oh, maybe I can draw the rectangle. So imagine we are drawing the, let's say, right rectangle, and hopefully this will let me do it. If we, oh, I can draw the rectangles. Good, 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 good. Imagine we are drawing the right rectangle like this. Like that, for example, right? Now let's see if this thing lets me write. And then this is f of x at the moment. Let's say that point is, that's really, really slow. X asterisk, because it's a certain x value, but it can be left, right, or middle, right? And then this is delta x. It'll eventually show up. Right, today Aries is slow and everything is so slow, right? So that area right there happens to be f of x asterisk. Yeah, it'll eventually show up. Dang. Right, today is that kind of one of those days, eh? Okay, and delta x. Delta x. You know what I mean? Delta x is this width and f of x is this height, which turns out to be a negative number. And I'm too afraid to actually calculate and plug it in because it'll take another 5 minutes to show up. Right, and does this thing make sense to you now, right? This is y value, f of x, and this is delta x. That's why that dx is here. You know what I'm saying? So from here to here, you do have to literally draw the rectangles and work this out. Rectangle approximations, like on the test everywhere. This gives you negative area. I mean, quote unquote, there's no such thing as negative area, but negative value, and that much gives you positive value, and this area is bigger than that one, so the net is negative something. That makes sense to you? Okay, well then, I have to do this next part, but let's see. I'll do the second one first, in case this doesn't work. Yeah, it doesn't work. Okay. I'm gonna have to display the Dropbox note, okay? Because it's clearly not working. Okay, this is what's in the Dropbox. Does this make sense to you? Because y is equal to x is just a linear function. And then we are calculating this area, but we are supposed to get positive. You get it? From 0 to 8, so this is 8, and height becomes 8 because y is equal to x. So we are just calculating the area of this triangle. You get it? 1/2 times 8 times 8. In this case, if you can feel this is a semicircle, can you feel the semicircle? And then, wow, then we use geometry once again, pi r squared, but this is a semicircle, divide that by 2. How about that? It would be so much better if I can just write it and, yeah, draw it and do that, but OneNote is not cooperating at the moment. Any questions? So for tonight's homework, mostly you're just doing this. You're using either algebra or geometry to calculate the area, but remember, when it goes below the x-axis, that actually gives you negative area, quote and unquote negative area. You get it? Any questions?
I have a question.
Yeah.
So if it goes below, then it's a negative area, but what if it goes to the left of the x-axis and also below? Is the increment negative or?
No, it's it's below. If it's like, regardless of which side of this y-axis, that's the question, right? It's always negative if it's below. Above is, but think of it, value of the function, if you're drawing the rectangle downward, that will be negative height. The width is always delta x, which is this entire thingy divided by number of rectangles. So that's how we got 0.5 in our case. Any other question?
Yeah, for that one, it goes below, but then it also like goes back above. So is it just like the negative minus the positive, or like?
Yeah, this is positive and this is negative. Oh, now I can write. It'll eventually show up. Sometimes it shows up and sometimes it doesn't. So this gives you positive area and this gives you negative area.
So just what the sum is?
Yeah, and then in this case, you have to take the difference and then bigger one wins.
Okay.
Good. Okay, any more questions? Yeah, Sarah.
Thank you. Yeah, Mr. Kim, I'm afraid I don't understand. Why do we like add the positive and negative area together? Because if we're supposed to find the total area under that, should we just add the absolute value of these two?
Oh, but then question says not to find the total area, although there will be that question on the test too. Then you have to take the absolute value, you're right. But in this case, it just says evaluate the integral. An integral gives you negative, positive net. Think of it this as a velocity and in a particle motion. So you're traveling backward for a while, and now you have to go back forward, and these two backward and forward displacement cancel each other. You know what I'm saying? So think in terms of physics, not geometry, really. We are just happen to be using geometry to calculate the physical area, but you have to know which one is positive and which one is negative. How's that?
Okay, that makes sense. Thank you so much.
Any other question? Kara.
Wait, so sorry, what would be an instance where we would add them instead of subtracting?
Yeah. If the question says find the area, when mathematicians say area, that means geometric positive area only. There's really no such thing as negative area.
Yeah.
All the calculus teachers use that term everywhere, but technically that's not a mathematical term. You know what I'm saying? When we say negative area, it means this case, right? The value of the integral is negative is all we mean, but then students get confused when we say it like that. So it's like we say negative area to enhance the understanding, but that's not really negative area. Okay?
So yeah, so if it has Riemann sum, then we subtract it? Or
whenever it says Riemann sum, it means just value of the integral. And then eventually, here we took 6 rectangles, but eventually I will show you how to take infinite rectangles.
Okay.
The delta x approaches 0. It's begging for a limit. I know that's the content of your quiz. Okay, now we're trying to approximate the volume, just like a rectangle, using rectangles to approximate the area. We are trying to approximate the volume of this hemisphere by cutting this thing 0 through 4 into 8 different rectangles, okay? But if you rotate this rectangle, does it create these little discs? You want me to, I have an animation, so why don't I animate it for you, okay? Just one sec, I have this thing, volume by resolution, okay. So this is a disc rotating idea, but it's not the same picture, but, oh, it's the same picture, okay. Let's put if I rotate this area, does it give you a sphere? Well, revolve this area, revolve, rotate. You know what I'm saying? This is the idea. Okay, now we can do that with a one rectangle. Not that. This one, right? So let's say if we have one rectangle and then revolve that. Amazing, isn't it? Then it gives you this stuff, right? And then if you put them together, and then these things kind of look like wedding cake, but it approximates the volume of this sphere. You with me? Okay, that's what we're doing. So here, each of this is a disk, okay? Cross-section of the disk. But why don't I draw it realistically then, huh? So let's say, because I got this thing, I have a computer, so why wouldn't I draw it? Say each disk looks like this. I'm going to put them right here. And then, why isn't it writing? Huh. My pen is not working. You get the idea? Say yes. Okay, now we'll figure out the dimension of this thingy. So let's say this thing runs through the center. Okay. Do you see this is y? Y from here to here. Let's say it's like that one right there. Let's say it's this one right here. You know what I'm saying? And then thickness is dx, or delta x, isn't it? In this case, happens to be 1/2. You get it? Say yes. So if this one is disk number 5, right? If this is A5, how do we calculate this volume? It's pi r squared h, isn't it? You can think of it as a cylinder, sideways cylinder. Say yes. Okay, that is pi, and what's the, well, this, right? Pi y square and delta x is a better formula. And then we literally plug it in, pi square root of 16 minus, this is 2 right here, isn't it? This left hand is 2 because it's a left rectangle. So 2 square and times 1/2. Somebody punch the calculator and tell me what this is. Not in terms of pi with everything.
I got 5.44139A.
44138. Okay. Okay, then while we are at it, why don't we just get a formula? So formula for that is AI, let's call it. This is like highly related to your lesson today about Riemann sum. Let's say I. Is that pi still y squared times delta x, isn't it? And that happens to be pi, and your y squared. Oh, shoot, y squared. I forgot to square this. Josh, you might have to run this number again. You know what I'm saying?
It's not showing. Oh, now it is.
Okay, I'm gonna delete this, and we might have to run because we have to square it, pi r squared. You get it? What's the number? On your
Doing it right
calculator.
now. 1 second.
Yeah, second entry. You know how to bring back the previous entry and then right arrow up and then just insert. Okay, and have it saved because we are going to run it many times. And you can actually program your calculator to do this. Okay, while he's doing that, then I'm going to say this y squared, of course, is 16 minus x. Let's call that x asterisk. X asterisk happens to be 2 right here. You know what I'm saying?
Oh,
Square. Let's not do that. Let's just call it square. X squared times delta x. You get it? Delta x being 1/2. This is the formula for all of these disks, the value. Did I call it A? Oh my God, I'm losing it. I have to call it V. These are no longer areas, right? Okay, Josh, what do you have?
18.849555. 556 actually.
84955.
556. Yeah.
556. You guys follow what's going on? And this is VI. Okay, then all of you have an assignment, at least 8 of you, right? So we can figure out V1, which is pi 16 minus 1 is this thing, 0. Oh, this is easy. 0 squared times 1/2. You know what I'm saying? This is first one, so we are using 0. And then V2, this is an algorithm. 16 minus 1/2, right? 0.5 squared times 1/2. Somebody else calculate this, V3. And then pi 16 minus now 1 squared. You with me? Okay, V4 pi 16 minus 1.5 squared and 1/2. V6 pi almost there, 16 minus 2 squared. Oh, we did this one. And V7, which is pi minus 16 minus. Do you know where I'm getting these things, right? Number, x value. And finally, V8 is pi 16 minus 3 squared. Wait, we're on 8 already?
What happened to V5?
Oh my God, I screwed up, right? This is 5. Ah! Okay. This is 5. This is 6. This is 7. Okay. Let's correct that. This is 5. This is 6. This is 7. So we need one more. So V8 is equal to pi and 16 minus 3.5 squared times 1/2. And then if you've done it once, all you have to do is just go back and change that entry. You know what I'm saying? You see the algorithm coming up? Okay, hopefully enough of you ran these numbers so we can have it. So whoever has a V1, spit it out.
25.132741.
Okay, V2.
24.740042.
42. V3.
23.5619.
5619 and
45.
45. Wow, she's the only one who did this, right? Oh my God! And you did it.
No, I mean,
Okay,
I
go
feel
ahead.
like interrupting.
Okay, go. Whoever's ready, go. And somebody add this up. Huh?
21.598.
Wait, was it 4598?
21.598.
Okay, 21.45. Say that again. 45.
21.598.
598. 598 and 3 more digits.
450.
450. Okay, somebody add this up as we go. B5.
18.8.
Oh, this is 18. I wrote 20. This goes way down. 18.849.
849. 556.
556 and B6. Can somebody else go now?
I can.
Mr. Kim,
Yeah.
I have a question on V4. I got like a slightly different number.
Whoa, somebody else confirmed. We need a tiebreaker now. Somebody else, third party, run the number on V4. Meanwhile,
I agree with Kara or Kara, however you say your name.
Depends. Is it Kamala or is it Kamala? That thing, right? Whoever.
Wait, Mr. Kim, I have a question on rounding.
Yeah.
Is it like if the 7th digit is higher than 5, we round it up, and if it's 1, 2, 3, 4, we round it?
Yes.
We don't round it, or?
Yes.
Because I got 21.59844949. So shouldn't you not round that?
You guys agree?
So 7th is a 4.
Okay, Matthew.
Yes, I calculated it and I got 21.598444949, which rounds to 21.598.
Yeah, my bad. Sorry.
50.
Okay, so we take this back. So is it 449 now?
No. 450 is good. It rounds to the 6 decimal places, right?
Oh, okay. What?
Wait, no, it's 449 because 6 decimal places it ends in 44949 and then 4 doesn't round 9 up.
The 7th is a 4, isn't it?
Yeah. Okay. You guys fight this out among yourselves. So, going with 449, well, half of you still don't agree, just like our election now, right? Whatever. Okay, this country will always be divided. We cannot have unity even on calculator-based calculation. Okay, V6, somebody go.
15.315264.
And V7.
10.995574.
5574. Okay, final one, V8.
5.890486.
486. Okay, somebody who's been diligently adding this up. V total.
146.084057.
08
4057.
057. You guys agree?
I can't actually tell if you got the number right because your screen's frozen.
Uh-oh. Wait, it does not agree with our answer key. Uh-oh, what have we
It's
done?
I think that one is 21.
Huh?
That one is 21 instead of 20, I think. I need to see the full question for it.
Oh, yeah. Oh, right. Let's go up to the answer key. 146.8406. Yes. Right, this is correct. How about that? How do you like it? Oh, okay, my screen is not updating in time. You'll eventually see it. Ryan.
Are we allowed to just add them all up in one equation and factor out h and pi? Or do we have to do it each separately?
In this case, it will work, but on the test, College Board and your teacher generally don't give you the same uniform width. So much for that factoring idea, huh? So you're playing a dangerous game, but in this case, if you have a same width, in this case, they are all 1/2 each, then you can factor it.
Okay,
And
thanks.
pi as well, right? That makes sense?
Yeah.
Okay, now one question I have is, so let me box this in. One question I have is, this is V8 and you only went to 3.5. Why is that? Why don't we go to 4? This is 4 right here. That kind of relates to number 21. See, it's clearly running from 0 to 4, but we never use this point. We threw this away. And this, if you memorize this process, you will always miss this part. You are not supposed to have 4, and the question is why.
Left side.
Speak up, you're breaking up.
Because we're measuring from the left side.
Left side. There's no rectangle here. Even if this curve does not end, if I draw it here, that's outside now, isn't it? You always, in case of left rectangle, you have to throw the rightmost point away. There's no dot there. Now, number 21, we are going to use the right rectangle. Then we have to throw this one away. You know what I'm saying? You follow? This is very important. One or the other needs to be thrown out, unless you're drawing with rectangle, because that thingy then, see, you're using this height of this rectangle, right? You cannot use it at both ends. It's like when you count this thing, 1, 2, something, 0 through something. Are we counting spaces or are we counting the lines? We're counting the spaces. That's why we don't use this, right? How many numbers are there between 0 and 5 inclusively? There are 6 of them, right? Right? Because you usually don't count 0 when you count. But if you count 0, 1, 2, 3, 4, 5, those are 6 numbers. But in this case, a rectangle is actually the spaces between the numbers, so you cannot count them twice. You know, you're overcounting it if you do. So either you throw this point out in case of left rectangle, or you have to throw this point out in case of right rectangle. You know what I'm saying? Otherwise, you have not at 8 rectangles. If you count both ends, then you end up with 9 rectangles. You don't see 9 rectangles here. There are only 8. You get it? Having said that, number 21 says, repeat this using the right rectangle, right? Well, instead of redoing all that work, why don't we just throw this one away and add the last one in? You know what I'm saying? But the last one, if I throw it here, well, throw this one and right rectangle here, this point, I'm gonna throw it with red so you can see it. If I use this point and throw it here, that rectangle has a height of 0 now, doesn't it? So all we have to do is just recycle our work, except throw this one out. You know what I'm saying? So somebody subtract this number from the total and tell me what that number is. I'm gonna write it here, V total. My pen doesn't work anymore. V total, in this case, is it better be 120.9 something. Oh, come on, you've done so well. Let's finish this.
120.951317.
95. 1317. UDA, which agrees with this answer key right there. Now can you see which is overestimate and which is underestimate? Because we are so used to thinking left rectangle is underestimate and right rectangle is overestimate, but this is the other way now, isn't it? Why is this thing underestimate? What is wrong with my pen? This is underestimation. Why is that? If I put this one on the test, this is over approximation, overestimation, right? Because as you can see, it's sticking out here. So it's over.
Is it because the rectangles are under the curve?
I know, but what causes this thing to be over in this case and it'll be under in this case? And this time it's not concavity. I know one of the test question was concavity, right? That is linear approximation depends on concavity. This Riemann sum idea, it will depend on, guess what you think?
Increasing, decreasing.
Increasing, decreasing, isn't it? See, let me draw it here. Say if the function is, I'm gonna draw it with a nice coordinate. Let's make that black. If the function is like that, increasing, and then if you, let's take left rectangles as an example. Let me just draw a few. Let's make that green rectangles. Say you're using left rectangles. And then don't memorize this, you have to just, this needs to be obvious by just imagining a few rectangles. See, this is the under approximation, isn't it? Approx. Right? However, if you have a same situation, still using left rectangle, say we have a function like that, or a coordinate like that, and then now our function is like doing that. Then if we draw the rectangles with the left rectangle now, I'm gonna draw one more. Now you can see this is clearly over approximation, right? So it really depends on the function is increasing or decreasing, right? So in this case, we can say that's because f prime of x is positive, increasing. And here, this is because f prime of x is negative. That means decreasing. How about that? That clearly puts everything to bed. You get it? Oh, this was great review. Any other questions? Okay,